Hello everyone. In this question it is asked that we are to prove that tan inverse of d divided by 1 plus a₁a₂ plus tan inverse d upon 1 plus a₂a₃ up to the summation goes on up to tan inverse d upon 1 plus a suffix n minus 1 times a suffix n is equal to tan inverse. In the numerator we have n minus 1 times d divided by 1 plus a₁a₁. It is given that a1 up to an forms an AP where small d is the common difference. Okay, so let us start the proof. In the solution, it is given that a1, a2 up to an form an AP. Okay, so from the definition of AP, we have a2 minus a1 will be equal to the difference of the third and the second term, will be equal to the difference of the next terms consecutively, which will go up to the difference of the last pair of terms, that is an minus 1. All these differences will be equal, and this is equal to the common difference, which is given to be d. Okay, so this is the first step. Okay, so let us now start with the left hand side of the given question. The first term is tan inverse of d upon 1 plus a1 a2 plus tan inverse d upon 1 plus a2 a3, and this goes on up to the last term, which is tan inverse d upon 1 plus an minus 1 times an. Okay, so see, in the denominator we have tan inverse plus tan inverse plus tan inverse. In the denominator of the first term we have 1 plus a1 a2. In the denominator of the second term we have 1 plus a2 a3, and so on up to the last term. In the denominator we are given that we have 1 plus an minus 1 times an. Okay, and in the above step we have written that a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3, and so on, is equal to an minus 1, and all of these differences are equal to d because these are in AP. Okay, so in the first term we can write the d to be equal to a2 minus a1 upon 1 plus a1 a2. In the second term we can write d to be equal to a3 minus a2 upon 1 plus a2 a3, and the summation goes on up to the last term where we can write d to be equal to an minus 1 upon 1 plus an minus 1 times an. Okay, so now this each term in the brackets, this becomes something like formula for tan inverse x minus tan inverse y, right? We have tan inverse of x minus y by 1 plus xy. Okay, so we can write the first term as tan inverse a2 minus tan inverse a1. This is the first term, and then in the second term we can write as a3 minus tan inverse a2, and so on up to the last term, which is tan inverse an minus tan inverse an minus 1. Okay, so if we see the first two terms, if we open the brackets, we see this a2 will get cancelled with this a2, right? Like this one gets cancelled here. Similarly, in the next term, which is written here, it will be tan inverse a4 minus tan inverse a3. So this will get cancelled out here, right? This will get cancelled out here. And the term previous to this last term, we will have tan inverse an minus 1 minus tan inverse an minus 2. So this also will get cancelled out with this one, right? So the only two terms that will be left are this, the last term, that is tan inverse an, and the first term, that is tan inverse a1. Okay, so now we will again apply tan inverse x minus y formula. Sorry, tan inverse x minus tan inverse y formula. Okay, so this will become an minus a1 upon 1 plus a1 an. Okay, now since this is an AP, right? AP, so if it is an AP, we can use the last term an will be the first term plus n minus 1 times the common difference, right? This is the default formula for the last term, nth term of an AP. So we can use this in this step. We can write tan inverse of this an becomes a1 plus your n minus 1 times d minus of a1. Okay, this is the numerator. We have just expanded the expression of an here in terms of a1, that is the nth term of an AP, and in the denominator we don't need to do anything, because after opening the brackets, this a1 and this a1 will get cancelled out. Okay, so in the numerator we will be left with n minus 1 times d divided by 1 plus a1 an. Okay, so this is equal to the RHS in the question, tan inverse n minus 1d upon 1 plus a1 times an, right? So we have proved it. Okay, we have proved it. While expanding, we have to carefully note that all these terms in the expansion here will get cancelled out. Tan inverse a2 will get cancelled out in this term, second term. Tan inverse a3 will get cancelled out in the third term. Similarly, tan inverse a4 will get cancelled out in the next term. The only two terms that will be left are the first term and the last term, that is tan inverse an and the negative of tan inverse a1. Okay, so this is it. Thank you.